So in AP Physics C, we actually use a different vector notation in addition to the vectors we talked about. And specifically, they like to use the I hat, J hat notation. It is not my favorite notation. If any of you have taken multivariable calculus, I prefer vector notations where we put brackets in here and we talk about the X component and the Y component like we do in Calc BC. But they like to use X hat and I hat and J hat for the vector notation and K hat. So for example, if we have a two-dimensional vector, you would think of it as the vector 3, -5. And so what that's describing is a vector that has an X component 3 and a Y component down 5. So that would be that vector right there. Okay, that vector where those are the different parts of it. So this is the resulting vector. This is the vector 3, -5. Instead, they would write that like using I hat, J hat notation. It's 3i hat minus 5j hat. The coefficient in front of the I hat is the X component. The coefficient in front of the J hat is the Y component. And so one of the reasons you do this notation is because this is the one advantage, and this is why we use this notation, is that because they have the same, you can use like kind of your normal algebra techniques to add them up. So when you add vectors, like this is the vector -2, 4, and we're adding it to this vector 1, -6, right? And when you add vectors, you add the X components and the Y components separately. That's the entire purpose of adding them. So here you could just say, like, if you were to add it with the normal, like the more bracketed vector notation, you add the X's. -2 plus 1 is -1. 4 minus 6 is -2. Or just by looking at this, you say, like, well, I have -2i plus 1i. That's -I hat. And then I have 4j minus 6j, that's minus 2j hat. And you see we get the same thing. That's the vector -1, that's in front of the I hat, and -2 here. And see how they match? Okay, so that's how the notation works. Everything else is identical. It's just this is a component form of the X and Y components of a vector. They're just given as coefficients in front of I hat and J hat. So let's look at a few examples where we do vector decomposition, and then we want to write the result using vector notation. And for all of these, we'll assume right is positive and up is positive. So if we do a vector decomposition of this guy, we're going to decompose it, right? This is the hypotenuse, so this is going to be 12 cosine 60 degrees. And cosine of 60 is 1/2, so this is going to be 6. And this is going to be 12 sine 60 degrees, right? So same, just like we did vector decomposition before. 12 sine of 60 is going to be 10.4. So in terms of vector notation, the X component's to the right, so it would be 6i hat. The Y component's 10.4, it's pointing down, so it's -10.4 j hat. Okay, and you look three-dimensional vectors. K hat is used for the z-axis when we get to more three-dimensional vectors. Right now in kinematics, we don't usually spend much time in three-dimensional vectors, but we will do that especially in the E&M portion. Okay, so then if we look at this force, we're going to decompose it this way, right? This is the decomposition. This is going to be 20 cosine 30 degrees. The opposite side is going to be 20 sine 30 degrees. Right, and so this is going to be 20 cosine 30 degrees, and that's going to give you, using your calculator, 17.3. 20 sine is going to be 10. And so again, using the same notation, right is the positive X and up is the positive Y, then our X is pointing to the left 17.3, so it's -17.3 because it's pointing left, I hat, and then it's pointing down at 10, so it's -10 J hat. And that's how you would write the component form with the I hat, J hat vectors, okay? Add the vectors A and B based on the description using vector notation. Okay, so again, similar thing here. You want to think of this vector as being, if we make right positive, this vector is 7i hat. This vector is -3i hat, because there's no up or down component. So the sum, you add those, you're going to get 4i hat, okay? This one, if you look at vector A, it's going to be 0i hat plus 5j hat. Why? Because there's no X component, right? So like if we make right positive, up positive. And then vector B here is going to be -3i hat because the X component's pointing to the left. And that has no Y component vector. And then if you add those two together, you're going to get -3i hat. And then 5 plus 0j hat is going to be plus 5j hat. So that means the resulting vector is going to have -3 in the x component, and 5 in the y component, just like that. Let's look at a vector like this in terms of theta. Let's split this apart here, and we'll call this is a sine theta, this is a cosine theta. So if you think about like this guy vector A is written as the x component, if we can make right positive and up positive, it would be a cosine theta I hat. The y component would be a sine theta j hat, right? Just like we do vector decomposition a couple lessons ago. The b vector is pointing down, so we'll make that negative b j hat because it's pointing down. And then you just add these two vectors together, a plus b. You're going to add the x components. This is the only one that has x components, so it's 8 cosine theta I hat. And notice that I didn't include an I hat here. You can put 0 I hat, but it doesn't matter. Like 0 is still 0, so you don't have to include it necessarily. And then this one, for the j hats, it would be a sine theta. If you factored out the j hat, then minus b j hat, like that. And so that would be the sum of those two vectors, right? So you're like when you add these two, the y components, you can factor out the j hat. So it'd be a sine theta minus b to get the j hat component there, like that. Thanks for checking out this video. I hope you found it really helpful. If you'd like more support, maybe you need more multiple choice practice, maybe you just need more guidance and things like that, I have plenty of information on my website. If you look in the description below and go to www.bothellstemcoach.com, I will explain all the ways I help students be successful in their AP classes.